So remember, the value of a stock today is simply the present value of all dividends that are expected forever and ever and ever and ever. Suppose we have a dividend that's fixed. It never changes. So if the dividend is the same, we'll call it D. What's the value of the stock? Just D over 1 plus R plus D over 1 plus R squared plus D over 1 plus R to the third forever and ever and ever and ever. But what's nice is through the magic of algebra, that simplifies, is that if the next dividend is in one period, and if that dividend stays the same forever and ever, you can get the price of the stock today as simply D over R. And again, remember, R is the appropriate expected return, the appropriate discount rate for one period, which is equal to the annual rate divided by basically how many dividends there are per year, how many periods there are per year. You can do a little bit of algebra if you want to know what the periodic rate is. You can get D divided by P0. If you want annual return, remember to multiply R by the number of periods per year. And if you know that you have a stock that pays dividends that are fixed forever and ever with the next one in a year, and you know what the return per period is, you know what the price is, you can figure out what that dividend is. Again, it's just through algebra, but you have unique expressions for each of the elements of the P0 equal D over R. More generally, if you take a time machine and get out, and you look ahead of you, and what do you see? Infinite stream of fixed dividends. What do we expect the price of the stock to be at this point in time? Just D over R. So it doesn't matter when you get out of your time machine, if what you see is the next dividend in one period, and then after that, regular, periodic, identical dividends, then the price at that point in time when you jump out of the time machine is equal to D over R. So suppose we have a stock. It's expected to pay $1 dividend every quarter forever. The expected return is 10% per year. The next dividend is expected in 3 months. So in 3 months we expect $1, 6 months we expect $1, 9 months we expect $1, forever and ever and ever. What's the current price today? Might be tempting to say, oh, $1 divided by 10%, boom, there's my price. Because you might recognize that it's $1 forever and ever and ever. But what's important is to recognize that this 10% per year is actually 10% per year, and that represents a quarter, represents a 3-month period. So what's the appropriate discount rate? 2.5%. Basically, here's a stock that's going to pay $1 every quarter forever. It has an expected return of 10% per year, which is equivalent to 2.5% per quarter. So the price of the stock is $40. Very important to make sure that the rate that you're using corresponds to one period. What do we want to know what the price of the stock is expected to be in 3 years? Stock pays $1 dividend every quarter forever. Return is 10%, and the next dividend is expected in 3 months. So basically, the stock we just looked at, what do we expect the price to be in 3 years? Well, 3 years is in 12 quarters. So we're going to get out of our time machine. And even though there's $1 that's going to be paid on that day, it gets paid in the morning, we value in the afternoon. And what do we see? We see $1, then we see $1 a year later, then we see $1 a year later, forever and ever and ever. So as of time 12, we're in a situation where in one period there's $1, and then after that, every 3 months, forever and ever and ever is $1. So what do we expect the price to be? Should look familiar because it's the same analysis we did when we were getting the price as of today. It's $40. What would the price of the stock? What's the price of the stock expected to be in 1,000,000 years? Well, we get out of our time machine in 1,000,000 years, and what do we expect? 3 months later, $1. 3 months later, after that, $1, then $1, then $1, then $1. So no matter when we get out, we're looking at the same thing. We expect, therefore, the price to be $40. And again, if the dividend's expected to remain constant, the price is expected to remain constant. Here we have a situation. We want to know what the expected dividend is expected to be in 3 months. Pays a constant dividend, so we know that whatever we find in 3 months will be the same for all these quarters. Expected return is 10% per year. So again, we're looking at quarterly dividends, so we know that that means 2.5% per quarter. Next dividend's in 3 months, and the stock is currently priced at $36.40. So basically, we want to know what is D such that D over 1.025 plus D over 1.025 squared plus D over 1.025 to the third forever and ever and ever is equal to 3640. But we say, wait a minute, this is a case where I got my next dividend in a year and then they're constant forever and ever. So I know P is equal to the price today, P0 is equal to D over R. I want to find D, so I can do some algebra. R times P0, I know P0 is 3640. R, 10% per year, so it's 2.5% per quarter. My dividend's 91 cents. What's the expected annual return for a stock? Every quarter, 81 cents, so 81 in 3 months, 6, 9, 12, 15, 18, forever and ever and ever. Next dividend's in 3 months, that's always good. If the next dividend's in one period, then I know my models are appropriate. The stock is priced at $27. So we basically want to know what is the discount rate, such as 81 over 1 plus R plus 81 over 1 plus R squared plus 81 over 1 plus R to the third forever and ever and ever is equal to 27. But again, we can say, aha, fixed constant dividend, next one in a period. So I know that 27 is equal to 81 over R. So I do a little bit of algebra. And R is equal to D over P0, which is 81 cents over $27. And I get R is 3%. But we're not done. 3% is 3% per quarter because it's the discount rate for this period, which is 3 months. So in order to annualize it, we multiply it by 4, and the expected annual return is 12%.